Applications. This graph is what's referred to as a learning curve. This shows what happens when we try to learn a new subject. At the very beginning, when we're just starting to learn something, the slope of this little piece of the curve here, or the rate of change, is very low. It's almost flat. And that's because in the very beginning you're learning language, you're really learning how to learn this subject. You don't know your resources very well in most cases, and it feels like for every hour or every day that you invest, you learn relatively little. Then what happens is at some point you get to what we refer to as the steep part of the learning curve. That's when you are immersed enough in the topic that you're learning that you really do get a lot more out of every hour that you invest. You know your resources, you understand what you're reading, and you're able to just turn that into productive work very quickly. Eventually, however, it goes back to something that's more similar to what you started with. It may take a long time to get there, depending on what the subject is. What happens is eventually, maybe you will have read every single book on the subject, and you'll already be familiar with all of the published work that others have done. And now, if you want to learn more, you have to start conducting your own experiments and finding your own human subjects, or whatever the topic may be. And so it slows back down again. We are assuming that we're talking about a topic that is deep enough that there's no such thing as knowing 100%. That you can't get to a point where there's absolutely nothing left to learn about this subject. But we have this kind of hypothetical limit of 100% here as what you can be approaching but never quite reach. And this behavior in the graph has a name also. This is called an asymptote. This is a word that will come up periodically in math. It has a funny spelling, a Y as a vowel and a silent P. All right, so we've got this graph and a few assumptions here. We're saying that the graph shown goes up to 100 years, but we should allow for indefinite learning. So that means the graph doesn't really end here. It really does have kind of an arrow where we're going to continue to approach that 100% but never quite reach it. So it also says amount known will get closer and closer to 100% as time passes but never quite reach it. We're going to use all of these assumptions to help us find the domain and range. First of all, looking at the domain. Certainly this graph does start at time 0 and knowledge 0%. We don't want to go into negative time. It's not possible to invest a negative amount of time into our learning, although with math some of us might try. Then it increases, and because we are allowing for indefinite learning, it does not stop at 100. It keeps going to infinity. So the first thing that we could note is that our domain is from 0 to infinity. Or we could say simply the set of all x such that x is greater than or equal to 0. Next, we're going to look at the range. And just like the domain, the range also, in this case, starts at 0. And as we go up the y-axis, we can see that all of these values are represented by our graph. But since our graph is going to approach this 100% and never quite reach it, what that means is that we do have an upper limit of 100, but I'm going to draw an open circle here indicating that we will get closer and closer to that 100%, but 100% itself is not in our range. We're going to represent that with a round parenthesis in our interval notation, or a strict inequality if we're using set builder notation. So the range starts at 0, goes up to 100 with a round parenthesis indicating that we never quite reach 100%. Or we could do this in set builder notation as the set of all y such that 0 is less than or equal to y, which is in turn less than, strictly less than, 100. So the never quite reaching 100% is indicated both by the strict inequality here and by the round bracket on our set builder notation.